ready to take all of our Colgan Creek measurements, starting with the physical habitat that's here, the container that is the creek. And here's our team that's going to be taking those measurements.
Hi, I'm Miss Brown. I'm going to be doing the pebble count.
Hi, I'm Miss M, and I will be measuring the creek riffle.
Hey everybody, I'm Miss Fleischer. I'm going to be helping with all the physical habitat measurements. This is the first measurement we're doing with the Stadia rod called the riffle measurement.
And I'm Miss Riddick, and I'm the videographer.
Make sure to fill out this worksheet today as you watch this video for our physical habitat measurement. You're going to fill up at the top for the California Bioassessment Worksheet this information: the stream and watershed, the date and time, class period, teacher, and reach and section number. It may look something like this. Pause to fill out the information. Next, on our data worksheet, we're going to fill out the site location. We used an iPhone 10 to find this information for the GPS, the latitude, the longitude. We weren't able to find the elevation, and our reach and section description is it is upstream of Burgess Drive. Pause this video to collect your data. Now I'm going to go over some of the tools we need for our creek work. We have this yard tape, a Stadia rod. We have boots to make sure that we don't get wet while we're in the creek taking measurements. We have this instrument to track our pebble count. We have a ping pong ball to measure the speed of the riffle. We have a stopwatch while we're measuring the speed of the riffle. We have a densiometer to measure canopy cover. And we have a clicker to help us with our trash count. Let's get started.
So we are going to describe this riffle in 3 dimensions, and we're going to put those measurements down as Miss M and Miss Fleischer are making those measurements. Let's take a look at them now.
And do I go to the very end of this clip?
Yes.
Okay.
So you'll see they are measuring from the top end where Miss M is to the bottom end of the riffle where Miss Fleischer is. They're getting a description of how long, and in this case, how short this little riffle is. And in a moment, they'll let me know the measurement, and I'm gonna write it down.
5.3.
5.3. They'll do that 3 more times because the riffle isn't a uniform shape. It's got different edges to it. It's not a rectangle or a square. So they'll continue to take these measurements until they have 4, and then we'll average those 4 together into the average riffle length.
And maybe here? Where do you think that, so it's where the rocks actually touch the water?
Yeah, and then it's actually behind your feet there. Yeah, I would go all the way to, yeah, even though it's not wetted, it kind of, the water sneaks around the edge.
This one could be like
right
here.
Yes.
Almost to right here.
Yes,
huh?
yeah.
Okay.
All right, 4th and final measurement.
9.2.
This is the 4th and final measurement.
All right, the riffle length has been measured. Now we're going to do the same idea, but we're going to measure the width. Right, so we're going to get a characteristic of how wide this riffle is. Again, different widths, so we'll take many different measurements. 1, 2, 3, 4, 5, 6 different measurements here.
Stephanie, could you share with us what's the importance of the riffle?
As you can see, and from the little video you saw before, a riffle is an area.
Keep going.
A riffle is an area where the water is being moved over the top of the substrate. So there's a lot of oxygenation happening there. The oxygen from the air is actually being mixed into the riffle as it moves and jars over the bottom of the creek. So it's an area where we're going to find hopefully a lot of aquatic macroinvertebrates, which is another measurement we'll be taking. So these riffle measurements, we're describing the container of the aquatic macroinvertebrates we're going to be talking to later. So we're describing the condition of where they live.
Go ahead and tell her the first.
7 and 6.3.
Got it.
Got it?
Yep.
5.8.
And then here.
7.2.
Nice job.
We are now going to record our data for the riffle number 1 characteristics. That's length, width, and depth. Please pause this video, record the length, width, and depth that was collected by Miss M and Miss Fleischer. And then you're going to calculate the average riffle length, average riffle width, and average riffle depth. Only the initial measurements were given to you, and you have to calculate the averages. Pause this video to collect the data.
Okay, the next thing we're going to do to measure the riffle is we're going to look and see what the embeddedness is. Embeddedness is the amount of, if there's any, super fine sediment, you could think of it like as mud or silt, that's kind of sliming or covering the larger gravel-sized pieces in the riffle. So we'll have a close look at that. I'll have these gals take a look. So they're going to be looking closely at the substrate to see how covered it is in finer pieces, mud or silt. They're looking to see if it's a low amount, a medium amount, or high amount. What do you think, Miss Fleischer? Miss
I'd
Em?
say like low to medium.
Yeah, I agree.
Okay, a low to medium amount. That's good news, and I agree as well. So we'll put a mark in between low to medium. All right, the next measurement we're going to take of the riffle is how consolidated, how stuck together is the riffle, or how not stuck together, how mushy is it. So we're gonna see Miss Fleischer and Miss M take the heel of their boot and kick around a little bit to see, is it stuck together like cement?
Yeah. Yes.
Is it mushy like just a
No.
lot of mushy mud, or in between? So they're looking
Oh,
for
it's
a
really
low,
stuck together.
Yeah.
a
very
low,
embedded.
medium, or high.
I would say high.
For sure.
All right, so that is a great description of the riffle we are looking at. It's not ideal, but it is good to know that we have high consolidation of this riffle. Okay, so the next set of measurements we're going to take about the riffle is the substrate, the different substrate sizes. Remember, we put in our drawing all the small to the large and everything in between. We want to have a diversity of substrate sizes. So we're going to be using this gravelometer as a way to measure randomly 100 different pieces of the substrate. Here's an example of one of those pieces. And what our measurers will be doing using this gravelometer is they'll randomly select a piece of the substrate, then they'll see which size it is by passing it through this gravelometer. So this one is too big, this one fits that rock, and then I'm just going to check this smaller size here, and it doesn't fit. So this will be known as a 9. We'll continue to look at the substrate until we've measured 100 different pieces. I'm so ready.
6. 5.
7.
0.
The 0 measurement is because she just found only silt, only just fine mud.
8.
5.
6.
7.
Miss M was really trying to get that piece to fit in.
1.
7.
6.
And we're going to continue this process until we have collected 100 different pieces of data on the substrate in the creek.
So
When we were finished with the substrate count, we used this table to record all of the data into fines, sands, gravel, cobble, boulder, and bedrock. Remember, we took 100 different samples. We are now going to go back to our California Bioassessment worksheet and find riffle number 1, substrate characteristics. We're going to pause this video and record our data for embeddedness and our percent substrate. Pause this video and record the data.
Okay, the next measurement we're going to take is how fast is the water flowing through the creek today. It's called stream flow. There's a certain amount of distance. We'll float a ping pong ball to see how fast it's going. We'll do that multiple times, and then we'll end up having how many feet per second is the creek flowing by looking at how many feet per second that ping pong ball is flowing.
okay, trial 1.
So you see Miss Brown's timing it,
Okay.
Stop.
Yeah. That was 4.31.
and then we'll repeat that 3 more times. How fast is that ping pong ball flowing? How fast is the water flowing?
All right. 4.62.
All right, 2 more.
Oops. Oh, do over.
We're floating at a distance of
Sorry,
4 feet.
Okay, I'm ready.
All right.
5.75.
And this will be our final measurement of how fast the creek is flowing today.
4.99. Was that enough?
Yeah. Now we'll average those 4 times together to come up with 1 time, and then we will divide that by the feet. We're floating that for 4 feet. So we'll have the equation of the average time divided by 4 feet. That's how many feet per second this creek is traveling.
You just saw your science teachers do the stream flow time trials. We are now going to pause this video and record the data. Please note that you need to come up with the average time measurements of measurements A through D. Those were in seconds. We gave you the time in seconds and the distance of the flow trial, which was 4 feet. After you calculate the average time measurements, you'll divide the riffle distance, 4 feet, by the average time, which you calculated. You will determine how many feet per second Colgan Creek is flowing for that riffle today.
Okay, so the next thing we're going to do is we're going to move now from the riffle. After all those riffle measurements we took, we're going to see if there are other habitat types on this section of creek. We're specifically looking for a pool. And remember, a pool is something that is 1.5 feet or deeper. So we're going to be looking around for that habitat type as I start to walk down the creek. I wanted you to look at my boots, because you can see by looking at my boots, I'm standing in the riffle. You can clearly see that my boot is not submerged at all, right? You can see the bottom of the creek and the top of the water are really close together. And then you can see my measurement tool is also indicating that. So watch as I begin to walk. So as I walk down, I can put my measurement tool ahead of me, make sure I'm not gonna get over my head. Now take a look at my boots. You can see I am in deeper water. I'm no longer in the riffle. I am technically in what we call a run. It's not deep enough to be a pool, but it's not as shallow as that riffle was. So I'm kind of just lightly measuring as I walk along as well. Remember, I'm looking for an area that's 1.5 feet deep or deeper. I'm actually gonna head over to this wad of willows over here. I happen to know that there has been before a pool there. All right, so if you take a look now, I'm in even deeper water. My measurement device, my Stadia rod, is telling me I'm at about 1 foot of depth. And so I'm going to go closer to where I'm thinking the pool is, and I'm just continuing to check with my Stadia rod the depth. I'm at about 1 foot and 1/10 of a foot. Same. We have a very, that's just 1 foot inside there. We have a very low flow drought year happening, so we don't have as much water as we normally do. We don't have as much flow as we normally do, and right now we don't have enough water volume to call this 1.2. This is the deepest so far. And I'm gonna just see if it gets, no it doesn't. So I'm gonna go to the other side of this and see if there's a deeper area on the other side of this willow bunch. All right, so good news is that the creek water just got over the top of my boots. So I then checked and I can see I found my deepest spot so far, 1 foot and 3/10 of a foot. So we are really close to having this area of the creek be considered a pool, but we're just not quite there yet. So I'm gonna keep checking. I just got some more water over my boot. Ooh. 1.35. Ooh, I'm at 1.4, but I still haven't reached that depth of 1.5, which is our technical pool depth. It's just making it difficult for me to find, that's all. I'm gonna extend my Stadia rod, and I'm gonna send it in ahead of me. This is where it'd be great to have you students here, because then we can be sharing this job of trying to measure. And I'm gonna just try to stand this up. I'm still always coming in under 1.5. All right, I'm gonna check one more spot. So close, you guys.
I'm going to film.
All right. And I have given up trying to stay dry, but I still haven't found a depth of 1.5. And this is what we're doing to check to see if this section of the creek has a pool in it. And I'm gonna check one more place. No, it goes back to a foot over there. All right, so we've checked. We have not found anything deep enough to be a pool in this section of the creek, so we don't have anything to measure when it comes to pool depth.
So now we're going to go to our data worksheet for pool characteristics. Now, unfortunately, we didn't find a pool today. Please pause this video and record the data. As you're recording the data, also calculate the cubic feet for the pool. This should be pretty simple since all of our measurements were 0. Pause the video and record your data.
All right, so we also took a look at the amount of trash pollution present in this section on the creek. We did that in 2 ways. One way was to go through the whole creek, counting up the actual pieces of trash that were here, trying to find them all. So we used this clicker counter. Every time we saw a piece of trash, we would add it to our count. And then we were also remembering what were the pieces of trash we were seeing, because the second part is to answer a survey. I just have another example of some trash that we found in the creek. The survey gives a score to different categories of what was that trash. Was it a threat to aquatic life? Was the trash full of human, things that could hurt humans' health? Was the trash coming from upstream and coming downstream, or was it coming from people littering? And so we answered all of those questions and we come up with a total score out of 130.
3 cigarette butts, and there's like another piece of like micro trash.
So right now we have Miss Brown at the start of our section on Colgan Creek, where the bridge is, right by Elsie Allen High School, and she's going to be surveying the trash, and she's using that clicker.
Cigarette butt and another piece of like fabric or something, and I'm using a little counter so I don't have to like keep track in my head.
And so we're going to survey the trash by counting how many pieces we see.
Okay, here's some, I don't know.
You can see we have Miss Brown up there with her clicker, and she's surveying the trash all the way from where the bridge started and this whole section of the creek. And she's just going to click every time she sees a piece of trash.
As Ms. Lennox stated before, this is a copy of the Rapid Trash Assessment Worksheet that we used to get our trash survey score. This was a visual score that we did. We're going to go to our data table now for trash survey. You're going to pause this video and record the data. We got 37 pieces of trash and a trash survey score of 75%. Pause the video and record this data.
Okay, so the next measurement we're taking around the riffle is how much canopy, how much vegetation is covering over that riffle. The measurement tool we're using, and you'll see Miss M and Miss Fleischer using it, is the densiometer. And what this is it's going to take a mirrored reflection of what's happening above you with the vegetation. So you'll see they'll be holding it like this. And then the mirror is reflecting the canopy that's above them. And then they're literally counting up how much of the canopy there is. So here we see Miss Fleischer. She's standing in the riffle and she's looking at how much canopy cover is above her, reflected in the mirror of that tool. She's carefully using the densiometer to calculate. And if we look over at Miss M, we'll see she's doing the same thing in a slightly different section of the riffle because canopy cover changes throughout the creek. I love it. Okay, now I'm going to give you this, or I'll just prompt you.
Here are samples of what Miss M saw when she faced in the different directions. She took a picture with her iPhone of the densiometer so that she could count accurately where the canopy cover was in that section of the creek. We are now going to record our last physical habitat measurement of the day, and that is canopy cover. We did 2 different sections, so you're going to have to add some stuff to your data table. We had section 1 and section 2, and we took 4 measurements for each of those sections. We then came up with our average canopy cover, which for section 1 was 68.02, and for section 2 was 33.44. And that's going to be telling us the percent canopy cover over those sections.